Okay, this time you have a balance. So this is a so we have a two-pan balance. Two-pan balance. So you can put things on this side, you can put things on this side. If they have equal weight, then it will be balanced. Otherwise, one side will drop to the bottom and the other will rise high. Is that okay? So if this side is heavier, then this will drop to the bottom. If this side is heavier, this will drop into the bottom. If they have the same weight, then it is balanced. Is that okay? Now suppose that I'm targeting to use this to measure objects. So I can have different kinds of objects. So I'm going to use this to measure objects with weight, with integral weight. So the weight has to be integer. With integral weight from 1 gram to 100 gram. Okay? So I'm going to use this to measure, okay, objects with weight from 1 gram to 100 gram. And then I can use some how do I call it? So I can use some carefully designed weights like this. Yeah. So I can have some carefully designed weights with known weights, so that I can use it to put on one side and put the object on the other side to check whether they are balanced. Is that okay? So this is my target. So I want to design the weights. So to serve this purpose. So how should the weights be designed? So if there is no particular criteria, then the simplest way is I can have 1 gram weight. So this is 1 gram. So this is 1 gram. Is that okay? And then I have 100 pieces of them. So if I prepare 100 pieces of the same 1 gram weight, I can use this to measure whatever weight that I want. Okay, but then this is very not easy to carry, because you have 100 little pieces. Okay, can we minimize? Can we decrease the number of weights here? So for instance, I can have what? I can have something like, I use 2 of them, and then I use 2 grams larger. Let's say this time I use 49 of them. Is that okay? Now this is also working. If I'm going to measure 100, then I use all of them. If I want to measure an even number not equal to 100, I only use this one. If I want to use odd number, I pick one here and then use all the 2 grams to help us to make the correct weight. Is that okay? Now this is a scheme that is much better in terms of the number of pieces. If you count it, so there are now only 51 pieces. Is that okay? Can we make the number of pieces even fewer? Can we make it, yeah. Can we reduce the number of pieces? Yes? Excellent. You get the solution. Very good. So 2 power. Okay. So one solution is this one. So let's have 1 gram. Let's have 2 gram. Let's have 4 gram. Let's have 8 gram. Up to the largest one. Let's say I have a 64 gram. Is that okay? This is one of the schemes that we may be using. So how many different kinds of weights that we are, how many pieces are there? So if you count it, 1, 2, 4, 8, 16, 32, 64. So we are using only 7 pieces. And then these 7 pieces is enough to give us any number from 1 to 100. The reason is that any number of 1 to 100, if you write it in binary, you can represent it in using 7 bits. For instance, I want to have a number 53. So if I write it into binary, 53 is equal to 32 plus 16 plus 4 and then plus 1. So this is a representation. 32 plus 16, so you get 48, right? 16, okay. You don't have any 8, but you have 4, then you get 52 now. You don't have 2, you have 1, then you get 53. Is that okay? Is that okay? So any number, so for this one, it needs only 6 bits, okay? So it is represented in 7 bits like this. So if I want to measure 53, then it is easy. I take out a 32, I take out a 16, I take out a 4, I take out a 1, then I can create 53. Is that okay? Is that okay? So 7 pieces. Okay, so this is a clever scheme. But then you may ask, can we do it with 6 pieces? This is the question. So you have already know 7 pieces is enough. Okay, is it the best scheme? Is it the optimal scheme? Can we do this with fewer number of pieces? 6, let's say with 6. Let me ask you something, okay? If you just have 1 piece, how many different kind of weights that you can measure? How many? 1. Okay, you can also call it, very good, you can call it 2. Okay, there are 2 actually. One is, so let's say you have a piece called 5 gram, so you can measure 0 gram. Yeah, 0 gram you can measure it, you don't use it. Or you can measure 5 grams. Is that okay? So there are 2 ways. You can think of this, including 0, as 2 ways. Now, if you have 2 different pieces, or you may have 2 pieces of the same, okay, how many different weights that you can measure? 4, at most 4, okay. Let's say if you have a 1 and a 2, then you can measure 0, you can measure 1, you can measure 2, you can also measure 3, okay. Let's say you have a 5 and a 7, and what can you measure? You can measure 0, right? You can measure 5, you can measure 7, you can measure 12. But if you are having 2 of them are the same, let's say 5 and 5, you can only measure 0, 5, and 10. Is that okay? But what I'm saying is that with 2 pieces, you can only measure at most 4 different kinds of things. At most. How do we know? How do we know? Let's say we have 2 weights. So weight 1, and then we have a weight 2. We see that to measure a particular weight, we will either be using this weight or not. And we will be using this weight or not. So there are 4 different ways. There are 4 different ways that we can choose the weight. So let's do it again. Let's say this is 5 gram, and let's say this is 7 gram. Is that okay? We can measure 0 gram. So 0 gram corresponds to I do not choose this one, and I do. Okay. 0 gram means that I'm not choosing the 1 and I'm not choosing the 2. Is that okay? I can also measure 5 gram. 5 gram means that I'm using 1, but I'm not using 2. Okay? I can measure 7 gram. I do not choose this, I choose this. Is that okay? Is that okay? And then I can also measure 12 grams. It is the case when I'm using both of these weights. Is that okay? Okay? Now, the question comes. This is a scheme that works with 7 pieces. But we want to argue that with only 6 pieces, it is not enough. The reason is simple. Okay? Let me change this. Okay. Okay, let's say this time with 6 pieces. With 6 pieces, we may have the first piece, 1. We may have the second piece, 2. So this is not about the weight, this is about this thing, okay? We may have the 6th side. Is that okay? Then what can we measure? We can measure 0 gram. Is that okay? 0 gram is when we don't have anything. 1, 2, 3, 4, 5, 6. Maybe we can measure a certain number of grams, x gram, let's say, by choosing this one only, but not the other. Is that okay? But for all the different kinds of weights that we can measure, we must be using a combination of the weights that we have, these 6 pieces. We either choose the first one or not choose the first one. We either choose the second one or not choose the second one. Is that okay? Okay? And so on and so forth. So how many ways, how many different ways that we can use these 6 pieces to create a value that we can measure? So 2 to the power 6. Okay, because there are 2 ways here, 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 and there are 2 ways here. Is that okay? So this time, each combination, we need to select whether we are using this or not, whether using this or not, and 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 whether using this or not. So this is a rule of product. Okay, so there altogether there are going to be 2 to the power 6 ways. 2 to the power 6 ways at most, because you cannot, because some of them may be measuring the same kind of thing. So with 6 different weights, there are 2 to the power 6 ways that we can think. Okay, 2 to the power 6 is equal to 64. Is that okay? So that's why using 6 pieces is not enough, because there are 100 different things we are going to measure, but we have only 64 different choices. Is that okay? So that means that 7 pieces is the optimal. You cannot make it fewer. Okay. Now, this is a related question. This is a related question. So here we are not that clever. So with a 2-pen balance, so this is one pen, this is another pen. Is that okay? Why restrict us to put all these standardized weights on one side and put the objects on the other one? Why don't we put something here and something here that we can still measure? Is that okay? Now, for instance, with 2 pieces, if we are always put them on one side, on the same side, so if we always put them on the same side, how many ways are there? How many ways that we can measure? So there are going to be 4 different ways. Is that okay? Use it or not use it. Use it or not use it. Okay? But if we can free to put it, so it may put it on one side or put it on another side. How many different weights that we can measure? So let's use a simple example. So suppose that one of them is 1 gram. Let's say the other one is 10 grams. Okay? How many different ways we can measure? We can measure 0. We can measure 1. We can measure 10. We can measure 9. We can measure 9. With 1 gram and 10 grams, we can measure 9. Is that okay? And we can measure 11. So there are more ways now. So if we are free to choose, there are now 5 ways. Okay. Okay, so in this case, if I still have the same target to measure all the different weights from 1 gram to 100 grams, how many pieces do I need? And why is it the minimum? Can you find the minimum number of pieces? So you need to design what are the different weights, standardized weights for each piece, and then tell me this works for 1 to 100. And you also want to tell me that no one can design a better scheme than you do. Okay, so I'll leave this as your assignment question. Okay, so we'll talk about this during the tutorial. Okay, but bear in mind, okay, if you know this, then you know a way to design, and then you know a way to argue that your design is good. Okay, okay, good. Okay, let me tell you one more example. So this is an excellent example as well. So suppose that it is known, we know that this number 1400, you can factorize it into primes like 2 to the power 3 times 5 to the power 2 times 7. So how can we quickly get this to check whether this is correct? Because a 2 and a 5 gives you a 10. So you have 2 2s and 2 5s give you 100. And it remains 2 and 7, so 14. 14 times 100 is 1400. Is that okay? So this is a correct factorization. Okay, and then we want to ask how many factors 100 this 1400 has. How many factors does it contain? So how many integers, positive integers, can properly divide this number? So 1 is a number, 2 is a number, 3 is not, 4 is okay. Is that okay? 5 okay, 6 okay, no, 6 is not okay, 7 okay, 8 okay, 9 is not okay, 10 okay, blah, blah, blah. How many are there? Okay, is there a quick way to find out how many factors that we can have for this 1400? How many ways are there? How many? 24? Yes. How do you get that? Very good. I heard 24. Who said 24? Yes? How do you get that? Okay, so he has a magic formula. Okay, so 4 times 3 times 2. But why? Why is it 4 times 3? How do you get 4? Okay, 4 is coming from 3 plus 1. Okay, 3 is coming from 2 plus 1. And 2 is coming from 1 plus 1. So where are this magic number coming from? It is coming from the power. Thank you. Okay. It's coming from the power here. To get a factor, for instance, 10. Okay, 10 is a factor. 10 can divide this 1400 properly. So 10 is equal to 2 times 5. Is that okay? Okay. As long as you can find 2, you can find 5 inside here that it has, okay, then it is okay. But then let's say 80 is equal to what? 80 is equal to 80 is equal to what? 80 is equal to 2 to the power 4 times 5. Is that okay? Now 80 is not a factor of this one because 1400 has only 3 2's. But then 80 contains 4 2's. So this one cannot properly divide this one, okay? If a number is a factor of 1400, then it must be in the form of this one. So each factor must be in the form of 2 to the power something times 3 to the power something times not 3. It must be in this form. 2 to the power something times 5 to the power something and times 7. Is that okay? And for this one, it can be a number not greater than 3. For this one, it can be a number not greater than 2. And for this one, it is a number that is not greater than 1. Is that okay? So for this one, there are 4 choices. You can choose 0 here. You can choose 1 here. You can choose 2 here. You can choose 3 here. Is that okay? You may be choosing no 2's. You may be choosing 1. You may be choosing 2. You may be choosing all the 2's. After you decide how many 2's are there in your factor, you can decide how many 5's are there in your factor. And then you can decide how many 7's are there in your factor. So there are 4 ways of choosing 2, which are you are not choosing any of them, 1, 2, or 3 of them. So there are 4 different ways. 3 ways of choosing 5, and then 2 ways of choosing 7. Is that okay? So if you know how to factorize a number, then you can quickly count the number of factors. Is that okay? Good. Okay, I'll give you one last example, and I will tell you, this is a simple example, but then difficult to get the solution quickly. If you know more, then you will find it more difficult. If you learn more things, then this will be a more difficult problem. If you don't know anything about this rule of sum, rule of product, maybe it is easy. So this time you have 5 Chinese books. 5 Chinese books, 7 English books, and then there are 10 French books. Okay. And then we want to do what? What do we want? We want 2 books of different language. So how many ways can we choose? Okay, so we have 5 Chinese books. So 5 of them are different. So you can imagine this is 鹿鼎记, 1, 2, 3, 4, 5. Okay, and then 7, you can think of this as Harry Potter, 1, 2, 3, 4, 5, 6, 7. Okay, so all of them are different. Okay, but then French, I don't know. Okay, somehow, okay, there are 10 of them. So I want to choose 2 books. Okay, so maybe this one, the third in the series, and then this one, the first in the series. So this is a combination. Okay, so how many ways are there that we can choose 2 books of different language? Okay, let's take a break, and then you can think about it. And then after the break, then I will ask Simon or Coco to help me to present the magic. Okay, okay, let's take a 10-minute break.